A little bit different today, which is to look at transverse waves, and in particular looking at the wave equation, which is given here, V equals F lambda. Now, transverse waves is basically this situation where any particle in the medium is actually moving perpendicular to the direction of energy transfer. So I'll play this animation in a moment, but this wave you have to think is moving to the right. And so the direction of energy transfer we can see is to the right of screen. And so when we look at this wave equation, we can start to think about, oh, how do we measure the speed of a wave as it moves through a specific medium? And I say that it moves through a medium, but certain waves don't move through mediums, such as light. Light's able to travel through a vacuum, so it actually doesn't need any medium. But in any case, to find the speed of a wave, you take the velocity, or the velocity is equal to F multiplied by lambda. So let's just break each one of these down. So the velocity V is in meters per second, just how you would typically measure speed. If you were running a race, you might be running 5 meters a second. It's a typical standard measure for measuring speed. F is what's called the frequency, and I think this is the trickiest part, so we'll talk about it in more detail. But the frequency is measured in hertz, and the units of that is just per second. Okay, Hertz was a famous physicist, I believe, but basically he got these units named after him. It just means 1/seconds or per second. And then the wavelength is this Greek letter lambda, and it's measured in meters. Okay, and the wavelength is basically the distance between 2 points that are at the same point on the curve. So for example, if you look at these black dots here, you can see that they're separated by 1 wavelength. So whatever that distance is in meters is our wavelength. So yeah, and just another thing to point out, when you multiply F by lambda, well, you're multiplying per seconds by meters. So you get meters per second. And, one real big tip that I got from my science at high school was, the units have to all work together, all right? So if you're multiplying a frequency and a wavelength in meters, when you multiply them together, you have to get the units of velocity. So it's going to be meters per second. Okay, and what we'll do now is we'll just change a few things and talk about a few other terms. This A stands for amplitude. Now, I just want you to imagine that there's a line going straight through the middle of this curve, pointing to the right, which is the direction of energy transfer. That's going to be called our center line. Now, the distance between the center line and the crest, or equivalently, the distance between the center line and a trough, is called the amplitude. Now, the amplitude is always positive, but you'll see as I change this, we can make the amplitude larger, okay? And if it's 0, then we obviously don't have any sort of wave going on. But let's just put it at 0.5 for now, but the amplitude is 0.5 meters at the moment. Okay, L is this lambda, because it doesn't like to use Greek letters for sliders. Just remember that this lambda is this L, and that's the wavelength. So if I make this larger, it's going to increase the distance between 2 points on the curve. So just keep your eye on 2 of those crests, and you'll notice that the distance between them gets larger. And so the wavelength is increased. Now the wavelength is 3, so it's 3 meters long. And then we can change it to 4, it gets longer and longer, or 4.5, and then 5. Okay, let's just put it back to something reasonable. Let's just make it 1. Let's make it 2. Okay, the frequency is a little bit tricky. Now remember, this is just per second. So it's basically asking you how many times does a full complete wave, or how many times does a point on a wave pass a specific, think of it as like some specific line per second. So this is where I really need to play it. So the frequency at the moment is set at 1. So I just want you to sort of look at this gate. See this dashed line here? We're going to look at this gate and we're going to ask ourselves how many times in 10 seconds does each wave pass that point. Okay, and I think you'll agree as I play it that we should get 10. If the frequency is 1, that means we're getting 1 wave passing per second. So if we play it, we should get 10, and I'll try and count it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, and then that was 10 seconds there. And we're back up at the same point on the wave, right? So that is the idea of frequency, and that can be the trickiest part. It's like, how many times does each point pass a specific point? And you're just counting it. It's like as if you've got a stopwatch. How many times does it pass that point? Now, just the last thing I want to mention as well is you probably noticed as this was moving along, that red point was just traveling up and down. So this is what makes it a transverse wave. That red point is moving perpendicular to the direction of energy transfer. Okay, so it's just sort of moving up and down. Now, it can be a bit hard to visualize that. I think when people think waves, they think of someone standing at the front of the wave and sort of moving through space. It's actually the medium that's moving up and down, and each point in that medium is just going perpendicular to the direction of energy transfer. And, a good way to think about this is imagine a duck is sitting on a pond, and then, nearby you drop a really large rock. As that wave hits that duck, the duck's going to go up, and then it's going to go down, and then up and down and up and down, perpendicular to the direction of energy transfer, which is sort of perpendicular to the duck. And I think that's a sort of useful analogy for sort of transverse waves here. I'll just change one other thing. So I'll just change the frequency to be 2. And here's a question for you. How many passes in 10 seconds, if the frequency is 2 now, how many times will each wave pass through that gate in 10 seconds? And it's going to be hard for me to count, but hopefully you're starting to see that it will be 20 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And then we're done. So you get the idea, hopefully. And so when you're applying this wave equation, you get V equals F lambda. Well, the velocity is going to be equal to the frequency, which is 2 at the moment, multiplied by the wavelength, which was also 2. So that tells us that our wave is traveling at 4 meters a second. And, I encourage you to get out a pen and paper and rearrange this formula, because sometimes you'll be asked to find the frequency when you get given the velocity and the wavelength. And you need to be able to rearrange that formula in order to find the relevant thing that you're looking for. Alternatively, just write it out as normal, substitute in the values, and then, do divisions and work out what exactly the unknown quantity is. But hopefully that makes a bit of sense. It's a fascinating topic. I encourage you to think a little bit more about longitudinal waves. Sound is a longitudinal wave. So go off, do some research, and good luck. Give us a thumbs up, enjoy, and I'll see you soon.